So this is 129S. We're down almost to the last class. There's just 3 classes left, including this one. So I'm going to finish the last chapter from the book that I'm going to cover today, Attacking Users, Other Techniques. There's a new book out on hacking APIs, and it looks good. So I'm going to prepare a lecture about that next time. That may be probably a project of some kind to do. There is a thing called Crappy, the completely ridiculous API that you can practice hacking with various tools, one of them including Burp, another one Postman. So I'll try and make a project about that so I can show you. And I don't know what I'm going to do for the last class. It might be more of the same. Oh, I see. Somebody says the university got hit by ransomware. Yeah. Well, if you put a link in the chat, I'll add it to my news. Anyway, so let's take a look at the last bit of this chapter 13, which is here. And then I got more demonstrations from the Web Security Academy, of course. All right. So more client-side injection. And looks good. All right. So suppose you specify the language in a get parameter. So you send a get, and there's a parameter saying the language, and the response contains the language in a cookie. Set cookie preferred language equals English. And of course, the same problem almost everything we've talked about is this is not filtered. This is data that came from the user that is echoed back from the server. So you can do things like cross-site scripting, and you can alter the response in other ways too. So you can do header injection. So if I could put in, I now have user-controlled data in the reply. So that means if I can inject carriage return line feed, then I can add multiple lines in that English. So I can add English carriage return line feed foo : bar. And then you'll now have a header of foo : bar. And I can put anything I want in here, so I can now add headers to a page. So, for example, now, of course, they might be filtering out carriage return line feed. So if they are, you might have to play the usual tricks to sneak them past, like put a null byte before them, double URL encode them, so the %25 is the code for %. Put it in twice, so removing one will leave one behind. You know, all the sort of tricks we've seen before to defeat various versions of content filtering. And then you can send this request, set cookie. Now, they're going to set a cookie preferred language equals English, and now I've told it to set another cookie, setting a session ID cookie. So now I can trick the recipient of this message into having a cookie set by me. And we're going to talk a lot more later about the many ways that can help you. All right. So you can also control the entire body of the response. You can inject not just a header, but you can inject the entire a whole fake web page in there. And so let's just take a look at that one. I've got a demonstration of that here. All right, so here's one where you can put in, say, a language like English. I'll make it bigger. All right, so if you send it a language and submit, and it's or HTTP, which it's complaining about, but I'll just send anyway. I don't care about that. Okay, so hello English speaker. It repeats the name here, and it's also in a cookie. And I should be able to see that, by the way, in Burp. Let me take a look at my proxy. Okay, so here it is. Here's the get language equals English. And here's the response. And you see it has language English up here in the header, and then a web page below that. So if I put in this junk down here, this is content length 28, followed by first a carriage return line feed after English. Then on the next line, I determine the content length to be 28. Then I put in 2 carriage returns. Then I put in HTML showing a page here, and so on. And then I put in the HTTP 200 OK, so I submit that, and now you see a totally different web page pwned. You can't see the URL. Oh, thanks for telling me. Let me make it down a little so you can. But anyway, the point is, now you see pwned, and if you look in Burp, you should be able to, there you can see, here's the request with English and all this junk, and here's the response. It determines the content length to be 28, so it's only going to accept 28 characters here, And after that, it's going to ignore this stuff. So even though this stuff is sent to your browser, it's ignored. And so if I look at the source code here, well, I guess it doesn't even send it to your browser. The only thing your browser now sees is the fake web page put in by the attacker. The original web page sent from the server is ignored. So that's fun. And you can do anything you want. And here's another fun one. You inject a lot more data. And now you'll see a whole fake web page with a picture and a form, and you have to enter your SSN and send it somewhere. You can inject a whole page with the content length, and it will then ignore all the original data. So anyway, good. So that's what it's like. And back to here. All right, you've seen that one. All right, so since you can do that, you can send a request to a server and have the response include a totally fake web page. You can also do that to proxy servers. All over the place, people have proxy servers to cache web content so that they have faster response. And so you could send a request to one of those proxy servers, and it will then save the response and serve it up to everybody for a while that looks for it. And you can make a split response so it serves the fake web page to all those people that try to see it. So that's good, clean fun. And if you want to prevent this, of course, don't use user-controllable data in the headers. If you have to, use input validation, output validation, block all the special characters like carriage return, line feed, the usual stuff. All right, and now you can do cookie injection. Like we saw, you could add a header that sets a cookie on somebody's machine who gets this response. And so, all right. So if there's such an invulnerability, you can set a cookie. Or you can also do it by cross-site scripting. You can set a cookie. And you can set a malicious cookie also if you're a man in the middle, of course. If you can modify traffic on the way down, you can add a cookie to be set there. And by the way, even if somebody is going to a site that is, all the cookies are flagged as secure, you can use SSL strip, which is a tool that serves pages up to people over HTTP and connects to the server over HTTPS. So even though the server thinks it's delivering a secure page, the fact that you're in the middle means you can downgrade that to an insecure page and modify the data. However, this is less valuable than it used to be because most browsers will now warn you, like mine did, if you try to use HTTP. They will pop up more and more increasingly rude messages saying, don't send anything over HTTP. All right, so you can set a cookie. You might find a cookie that actually does something directly, like use HTTPS equals false. You might be able to inject things like DOM-based cross-site scripting if cookie values are used and somehow displayed on the page. Sometimes anti-CSRF tokens, instead of putting a hidden field on a page and checking that it's the right value on the server, they just put something in both the cookie and the request parameter and compare them, and then you can control both and bypass that defense, so that's rude. All right. And so if you have a persistent cross-site scripting vuln, you can use cross-site request forgery to trick them into loading the script, but you can also put your own session token into somebody's cookie. And that exploits this thing called session fixation, which is this attack to understand. This comes from a flaw. When you first connect to a server, before you log in, the server might send you a session cookie. And then when you log in, it might keep using the same session cookie. This is a mistake. And that's the problem. The same cookie refers to an unauthenticated and an authenticated state. And what that means is, if I can set the cookie first, or trick you into using my cookie, then you're using a value I know. So here's the trick. First I go to the login page and get a token. Then I feed the token to the user with some trick like this header manipulation, where I get them to open a page that will include, they'll set a cookie on their machine. Now they log in, and the application believes that that token came from the application, and now they log in, but their session cookie is something I know. Now I can just take over their session anytime. So that works very well. I did that for a lot of websites years ago, checking for this. All right, so you can do it with cookie injection. If the token is in the URL, you can just put it right in the URL and then collect them to somehow use a malicious URL that has the token up there. Sometimes you can add it even when they don't expect it. And if it's in a hidden HTML field, you can use cross-site request forgery to insert the data. All right, so here, by the way, even if there is no login, sometimes knowledge of the session token gives you the sensitive data. A little lost on how that works. Wouldn't that get the victim to log into your account? Oh, yes. If the attacker actually logged in, then the victim would end up in your account. So what the attacker does is just connect and then not log in. They get a session token, but they don't log in. Yes, and that, Hema, that's exactly the question. This is for websites that do sometimes send session tokens before you log in. By the way, a lot of them do for other purposes like ad tracking. But if they are sloppy, they continue to use the same token after you log in. It makes more sense to always give you a fresh token every time your status changes. They should just give you a new session token after you log in, and that would fix this problem. But it is something a lot of people don't do. All right. And so, by the way, even if there's no login, just knowledge of your session token might reveal something sensitive, because suppose you put something in a shopping cart, then you fill in your address, maybe even your credit card number. You might do all that up to the confirm order page before you log in, or indeed you can buy things without ever logging in. I've done it, buy things as a guest. So even though you never logged in, knowledge of your session token would allow the attacker to view that confirm order page and see your sensitive data. So it's session fixation is dangerous. By the way, some apps will just let you put in an arbitrary token like 1 or 0. Then you'll see you don't even have to give it the right length or anything. So that's even handy. Microsoft IS and Alere Cold Fusion let you do that, so you don't even need to do the first stage of going to the page to get a valid token. All right, so if you want to find these things, just watch how session tokens are used. One vulnerability is the one I talked about, where the same token replies to an anonymous user and to a logged in user. And another one is if you log in and then log into a different account, you still have the same token. These are various things that can go wrong. Obviously, you should just assign a new session token to every authentication. And this talks to one I've talked about before that I did a lot of talks about years ago, where a website, you can just take an old token you stole from before and get in a page, even though that person is logged out in the meantime. A lot of websites have that flaw. So you get a valid session token, feed it to the target user. When they log in, I know their session token, and I can get in their session. Session fixation is for man in the middle of the age of HTTPS without a... Well, yes, you can do it that way, but session fixation can work without being a man in the middle, as long as you can trick them into clicking on some URL. Like you could email them a link to click on, and that will include the token when they log in. So you don't need to be man in the middle, although being a man in the middle is one way to deliver the malicious session cookie. So if you want to prevent this, issue a fresh token every time they transition from one state to another. Employ per-page tokens to supplement the main session token to make sure they really came from your page. And it shouldn't accept arbitrary session tokens. Your app should only accept session tokens it issued themselves. Yeah, I'm glad to see these questions. A lot of good questions in the chat. All right, so then there's open redirection, a common flaw where you have a URL that has some kind of redirect to another URL. This is commonly used just as a stunt to make people see a funny page. You can use it for phishing attacks. If Google has a open redirect, you can have a URL that starts at Google but goes somewhere else. And this is why you'll see a lot of web pages now have a box that pops up saying, wait, you're leaving our domain, you're going somewhere else, to warn you when this happens. But in fact, real-world phishing attacks don't usually use this open redirection. They usually register a similar name or just conceal the name, so it's not easy to see the URL you're clicking on. Yeah. So you can have a 302 redirect where you go to a page and the server tells you that page is moved. There's something called an HTTP refresh header I've never used, which is another way to do the same thing with a 200 status. And there's this one I've used all the time, HTML meta tag in the head that redirects to a new page. And these things are all over the web because people keep updating their website, and they have redirects all over the place to make people that go to the old link find their way to the new link. You can do it with JavaScript too. You can use document location to redirect to a new page. This isn't that common, I think, because they don't trust everybody to always have JavaScript turned on, although these days I think you probably can expect everybody to have JavaScript turned on. So open redirects, they shouldn't be user controllable, but sometimes they are. And for example, Hackazon here, when you log into this thing, I didn't use it much this semester because we got the Web Security Academy, but it's a training product to fake Amazon you can hack into, and it has a lot of vulnerabilities. And one of them is when you log in, after the successful login, it will go to this URL up here, return URL, and you can just put a different URL up there. And then after you log in, it'll redirect to a different page. So that's what open redirects look like. You have some kind of parameter, which is a website, which tells it where to go next, and you can modify it. So you can trick the page into redirecting to an unexpected place. So if you want to prevent this, you can try blocking URLs or adding a specific prefix. And it's pretty easy to think you have protected yourself and still remain vulnerable. For example, if you block user-supplied strings that start with HTTP, you might be able to sneak it by with the old tricks like null bytes, or even just 2 backslashes, or encoding the HTTP, or double encoding the HTTP, or using HTTPS instead, or backslashes, or 3 forward slashes. You know, any modified version of it might slip through. And if they're going to remove HTTP in any external domain, you can maybe just duplicate things, or you put it in twice. So when they remove one, there'll be one left. Put in the HTTP twice, that sort of thing. Any of these modified versions might slip through a filter. Now, they might verify that the user-supplied string starts with the correct domain name. Like you're making sure you go to mdsec.net, but if you're making sure you're going to mdsec.net, I could just put .mdattacker.net, and then this will be considered a subdomain in here under my control. You're still going to the wrong place. Or I can put in a punctuation mark, which will cause it to ignore this one and use the next one, I think, although you'd have to try this to see exactly how it works in browsers. And another thing they do is apply an absolute prefix. So it will always go to here. The only part you control is this part, updates, update 29. You don't control this part here. So you might think that's safe, but it's only safe if you remember to include the slash. If you don't include the slash, then I can put a dot here and make your desired domain a subdomain of mine, and then I can still redirect to a different server under my control. All right, so if you want to prevent these things, of course, it's the same old stuff. Don't let users control parameters that end up in a URL. If you have to make them choose from a list of known targets, is safer. You could use relative URLs on everything. Prepend every URL with the domain you want with a slash here, so anything added after that will not change the fact that you're still going to this one. Verify that every URL starts with that. There's various ways to do it. All right. And by the way, this is something I've never seen used yet, but supposedly HTML5 lets you have a database stored in the browser. Not just cookies, but a whole database. You can open a database, you can create tables, you can insert data into tables, all in the browser. So you could have a whole SQL table locally. And then, of course, you could have SQL injection and everything running locally in the browser, not going to a server. So you might be able to steal the data that's in there, whatever it's saved, your social networks or comments or whatever the heck. And you might be able to use parameter pollution to steal that stuff. Oh, here's another one. So if I have a web app that loads your inbox with this parameter, show, and then it has some parameters here, folder equals inbox, the order, how many emails show on a page, which one to start from, and I control some of these. When you reply to a message, then it's going to make the reply request using some of those parameters that were under my control. So if I can trick you Is it about, yes, I think this is about the database available in browser developer tools. I think we saw it there. And I've never seen anybody actually use it. It's a HTML5 feature that exists, but I've never seen anybody use it. I guess somebody must be using it. Anyway, so here you got parameters like the start is included when they try to send an email. So that means if I can inject extra characters in this start parameter, then I can change the reply to delete. So when you think you're replying, I added an extra action equals delete here, and that's what will take effect. Oh, you saw an example of someone using it. Oh, that's good. Yeah, I mean, it's there. Somebody must be using it, but it's not very common, I think. Here, let's take a look at some Cahoots. Yeah, done to implement a game. I know. I haven't seen anybody use it at all, and let alone use it for any like realistic purpose. By the way, you want to know something funny? Caitlin told me there are some smart speakers where you can talk and then say the word apostrophe and perform SQL injection on them. So apparently the stuff you speak is turned to text and typed in, and then there's SQL injection. That would be fun. Anyway. All right, let's give this stuff a try. All right, so what method has the same cookie before and after authentication? All right, that's session fixation. All right. All right, what attack will replace the entire HTML code? All right, that's response splitting, where you inject a whole extra page by modifying parameters starting in the header. All right, so which one is mostly a prank, not very serious? Yeah, there's always a lag between the Kahoot and the Twitch. It varies. Yeah. All right. If I stop and restart the stream, it might get a little better. All right. So what attack can poison a proxy server so many people see an altered page? Well, it's only 10 seconds for me. I can see the countdown. A minute is pretty bad, but I think it's not the same for every viewer. I think that's part of why it takes a long time for people to join the Kahoots. They're actually seeing my presentation at different lags. Well, let me record these and then I'll stop and restart it to try to cut down the lag. Okay. And Eileen, okay. All right. Well, all right, I'm going to stop the stream and restart it after about 30 seconds just to see if I can make the lag less annoying. All right. Now I think I have to wait until the old stream stops, and probably, I think refreshing this page helps. Okay, and now I start streaming again. Well, it's taken a long time to connect. I could not access the channel. Okay. Well, now it looks like it worked. Oh, okay. All right. 1, 2, 3. Okay, now it's only 3 seconds here. It might be a little better. Anyway, we'll see when we get to the last Kahoots if it got any better. All right. So local privacy attacks. Things that might cause your data to end up in somebody else's hands. If you're going to have access to the same computer, like a shared computer in a lab, or if you steal a cell phone or a laptop, that's one option. And then you might wonder what's going to happen. One thing, of course, is if you have logged in sessions like you do on your phone, right? I never type my password again in any of my apps. I click on the app and it already goes up. So if somebody knew my PIN code, or if they got my phone while it was unlocked, they could certainly just use all my apps. They're already logged in and they won't ask for re-authentication, except for a few very secure ones, like my two-factor authentication tokens will verify my face every time. Another thing is your browsers cache content. To make pages load faster, browsers save images and other things from pages, and they typically do it all the time automatically, unless you tell it not to, like cache control no cache and pragma no cache in headers. The browser will make its own decision and typically cache quite a lot of content, and forensic examiners know this. You can look at the web cache and you will find fragments of images and pages people have been looking at and get some information about what they've been doing on the web. Also, your browsing history, well, if I just use the back button and so on, it records all the URLs you've been to. Autocomplete stores passwords, credit card numbers, etc. And sometimes that can even be stolen remotely by cross-site scripting. Flash, pretty much gone now, but Flash used to have its own cookies called local stored objects, and Google used them to mark you so that even if you cleaned all your cookies off, they would still know who you are. And I'm sure they have another dozen ways to do that too. That's why trying to hide who you are from Google is pretty much a lost cause. Internet Explorer has a custom user storage system, and it stores local data even in private browsing mode, which got some people upset in 2016. Private mode doesn't mean it doesn't store data locally on your system. And HTML5 has a bunch of these things: session storage, local storage, and that database storage we were talking about last time. And so it may be that some of that stuff can be stolen by attacks, but it's not clear yet, at least as of the time your book was written. So in order to prevent these things, you shouldn't be storing sensitive things in a cookie, and you should use the cache directives to prevent sensitive data being stored by browsers. So there's various, each language has a way to do this. Here's ASP and Java. You can tell it to put on these things. Expires equals 0 means it'll throw it away when the browser closes or when the page closes. All right, and I thought there was more of those. All right, anyway, so you shouldn't use the URL. We mentioned this many times. There shouldn't be anything sensitive like a password in the URL, because that's stored in favorites, and it's stored in server logs and so on. Everything sensitive should be transmitted as post data. And you can use the autocomplete equal off HTML attribute in forms, and that will mean that it will not offer to fill in the content. You've probably noticed this. If you go to a field in a browser and start typing letters, it will suggest things, and you can prevent it from doing that with autocomplete equals off, which is good because it will suggest what the previous user typed in there. All right. And then you can attack the browser. JavaScript can monitor key presses, and so you can make scripts that steal data from the server. Now this script they put here, where it puts it in a status code, that only worked in really old browsers like on Windows 2008. You could type stuff up here and then it would show up down here, I'm in your browser stealing your cookies, you know. It'd end up down here in the status bar. That's not that useful, but here's one that works. Let me bring that up. This one here works. Let's make it bigger. All right, so you type secret information here like secrets, and then you go to this page, and there's the secrets, plus some other stuff I had earlier when testing it. So the way it works is here is just a script. On key press, it calls the function of E, and here's the function, which I don't know about this image nonsense, but the point is somehow it sends it here, keylog php data equals. And I used a script that just takes data and puts it in a temporary file. So it resolves this URL and puts your key presses in there as the data parameter. And there's a PHP script there that just puts it in a local file. So this works, as you can see. All right. Works in Brave and works in Chromium. As you just saw, it works in Firefox. All right. But it can only capture keystrokes while the frame with the script is in focus. And so if you embed a widget on the page, that might make you vulnerable. There's also reverse stroke jacking, where code in a child window, like say a Twitter widget, could reach up and steal focus from the top level window. So it could echo key presses to the top level window. So it could be sniffing your top level window. We talked about this before in frame busting. You can't trust scripts to stay inside a frame. So JavaScript can try a bunch of URLs, and it can go check to see if they have been visited. But this has supposedly been fixed a long time ago, so it shouldn't apply to modern browsers. And that was the sort of thing people would use to like pop up a box saying, you've been going to porn websites, I'm going to tell everybody unless you pay me money. And they would be able to tell you really had been to porn websites with this attack. All right, you can determine if people are currently logged in to third-party applications by just requesting a page, and then you'll either get an error or you won't. You won't be able to see the request that comes from another domain, but you will know if it had an error, and therefore you can tell. For example, that caused the error will have a different line number and error type, so you can tell if they're logged in or not. And then you can do a sort of port scanning from inside a browser, although it's really quite limited. You can't see the response, so what you have to do is try to dynamically run script from each port, and the script will, if there's a web server, it'll return HTML, and that will create a JavaScript error. So you can sort of detect some servers, and you do some port scanning, but the browser will stop you from scanning ports like 25 and other ones it thinks are too dangerous. So it's not at all as good as, actually installing Nmap on a machine and running a scan. You can actually attack other websites. You can try to fingerprint them, like here, for example, would tell you if you have a Netgear router. See if you have this GIF present on this domain, and see if that'll give you if it finds it, then that means you have a Netgear. I don't know, Akaren. I have not updated this thing lately, but it's possible that whatever's on my website is not the latest version. But I checked it before class, and I did not add anything new, so I thought it was all right. Anyway, so after you identify the device, you can try default username and password or other known vulnerabilities. And like we talked about this before, you do have the problem that you can't see the response, but just like blind SQL injection, you can still do things even when you can't see the response. It's just harder. All right. And so you can send arbitrary binary data to a port, but it's always going to start with an HTTP header. So if you're trying to attack some other service, it's going to have to tolerate extra junk data, which a surprising number of services do. All right. So if your service will tolerate unexpected HTTP headers, then you might be able to execute certain kinds of attacks. But this seems a little bit complicated and esoteric. I've never used it. It might be somewhere in the Web Security Academy, but I kind of doubt it. By the way, here's a fun fact. I should test this sometimes to say if you go to a website with a domain and then you go to that domain with a port number, it will not remember the port number. It will send the cookies to every port number. So that's interesting. And all right. And if you have bugs in the browser or the extension, you might be able to exploit them. There have been Java bugs that would let you do two-way binary communication from the browser and use the browser as sort of a bot. There were various products that did this in various ways. They're always pretty weak, and they patch browsers pretty fast, so those things don't last too long. Here's another attack I got pretty excited about 5 years ago, but it never seemed to go anywhere. DNS rebinding works by having a DNS server under your control. So when you resolve domain names, it sometimes resolves to the real address and sometimes resolves to 127.0.0.1. And the idea being you can arrange it so there's a possibility that you load my page and then there's a script or a link to click or something. And when you click on that link, sometimes instead of going to my server, it will go to your local server and it will resolve as coming from 127.0.0.1. So I can send a request which appears to come from the local host. That's the basic point here. And so that you call that DNS rebinding, where you make a DNS server that keeps changing the address. And so the browser thinks the target app is in the attacker's domain. The same origin policy doesn't block the responses. That's the idea. And the main point of this is to attack Internet of Things devices in your house, like your thermostat and your garage door, by making it think that requests that came from an internet script are in fact coming from a local source. And it turned out to be extremely hard to do. I tried to make a project for the students for this years ago, and it took hours and had like a very small chance of working. Various people made other versions of it. Scripts you could run. It would do many GET requests, trying to get this magic situation where the domain name that it's coming from does a resolution at the right time, and that resolution comes out to a local IP address. There's a few of these. Here's another tool called Singularity of Origin that supposedly can do it better. Various people wrote tools about 5 years ago. I never heard any more about this, though, so I think it did not turn out to be as big a problem as people expected. But there are some tools that will perform that somewhat complicated attack. And Beef is one of the ones, the browser exploitation framework where it just came out maybe 10 years ago and people trumpeted it was going to be like Metasploit, but it turned out that all the exciting stuff got patched pretty fast and you really can't do as much with it. You'd view a web page, it would run some JavaScript, and then you could do things, do these various kinds of attacks from your browser. So they said it makes your browser into a bot, and I can now attack the network. But I had great trouble finding any attacks that really did much after the first year or two. Anyway, in principle, it can log keystrokes, hijack a session, fingerprint your browser, perform these limited kind of port scans, and attack other web applications with these restricted kinds of attacks, brute force your history, and send it back. These are things that might be possible. But a lot of it's been patched with modern browsers. And then, of course, as we've been talking before, if you can be the man in the middle, if you can actually intercept data and modify it, then, of course, you can do anything you want if they're using HTTP. But if they're using HTTPS, then you can't. However, there are mixed pages where the main page is HTTPS, but some of the content loads over HTTP. So you'll have something like a script that loads over HTTP on a page that's otherwise HTTPS, and then, of course, you can modify that. And that's not good. All right. And you can, of course, modify a response to force a user to reload the page over HTTPS. But even if they do that, the script will still load over HTTP because it's explicitly, there's an HTTP in the HTML tag to load that script. And this is a way perhaps to trick the browser into not giving you the warning about an unsafe page, but still have some unsafe content. There are domains like Google, years ago switched to 100% HTTPS for everything to try to stop these attacks. And sometimes you can, if you're in the middle, you can make a request over HTTP. And you can reply to them with fake content, and their browser might accept it. But I think these days you would get a warning that you're loading a page over HTTP. All right. And so they say sometimes you can update a cookie that's then used in HTTPS sessions. And there might be some way to have, when stuff you injected over HTTP have an effect on an HTTPS session. But it's getting kind of complicated. And, all right, they say some extensions don't separate the content. Anyway, you have to find something like that. But I think these days people are using pretty much HTTPS all the time, and that makes the value of these attacks a lot lower. Anyway, let's try some more Cahoots. 13b2. Good. Well, maybe that's it. All right. The lag is down to 3 seconds here. Don't know if it's better for you folks. All right. So what persistent data is created for HTTP pages, but not for secure pages? does only caches insecure content. That would make sense. HTTPS content is not cached, which, by the way, would make it seem like browser caches are going to be a lot less useful these days. Now almost everything is HTTPS. But I guess it doesn't matter because internet speeds are a lot faster now. All right, which data comes from a browser plugin? Yeah, the LSOs. Local stored objects are flash cookies. Probably not really relevant anymore. I should probably take that one out. Anyway. Probably matters in other countries. All right, what method will evade the same origin policy? Yeah, DNS rebinding tricks your browser into thinking that a web address is in fact a local address on your local network when it works. All right, and which item will let a script in a frame grab input from the containing frame? So something like a Twitter widget could steal data from the page about outside it. Yeah, they call that reverse stroke jacking. All right, which one only works if target processes ignore extra data? Yep, you can exploit a non-HTTP service, but the only thing your browser can send is an HTTP request, so it has to be tolerant of a request that includes extra junk. All right. All right.